Okay, evaluating functions. Pretty simple. It's just another way of saying, hey, substitute in the value that I want you to do. So in this case, I have the function f of x is equivalent to 3x plus 3x plus 1, and then I have the semicolon f of 9. And what that f of 9 is saying is that for my function, input the value 9. So I'm going to go ahead and do that. So f of x is now, I want to know what f of 9 is. And that's equivalent to, wherever there was an x up here, I replaced with a 9. So in the actual work, I'm just going to do this input of 9. So I get 3 times 9 plus 1. And for my input, what I want you to know, no matter what the value is, I'm always going to put it in parentheses to show that multiplication, or I'm just going to put it in parentheses as is, because sometimes it's very, very important to do that. So now I'm just going to go ahead and evaluate it. So I've got f of 9, 3 times 9, which is 27, add 1. So in this case, I get 27 plus 1, which is 28. So therefore, if I were to write this in coordinate pairs, my input x value is 9 and my output is 28. And the whole reason I evaluate functions is to create coordinate pairs so I can draw its picture. So I hope that helps for evaluating functions of f of x notation. I am now going to continue on with another type of function. And the type of function I'm going to continue on is going to be the idea is what happens if I had written this as y equals 2/3 x plus 5, and now I'm going to write it up as over a certain domain. So I'm going to write over the domain of, and in brackets here, I'm going to put 3 and 6. So what this is asking you to do is if it says over the domain of 3 and 6, remember that domain just means x values. So this function up here, it's just saying, hey, plug in 3, then plug in 6, and you're going to get 2 different answers because there's 2 numbers. And that's okay because there are millions of coordinate pairs on a function. And in this particular case, when I go through, I do y equals 2/3 times 3 plus 5. So y is equivalent to 2 plus 2/3 times 3 is 2. And 2 plus 5 is 7. So I have y is 7. So for this particular case, my input-output values are my x is 3 and my y is 7. If I were to do this again, vice versa, where I have y equals 2/3 of 6 and I add 5, 2/3 of 6 is 4. 4 plus 5 is 9. So what I'm left with is an input of 6 and an output of 9. So what I have now is over the domain, if this were my graph, these points would be on this function's picture. And the function's picture would go through the points 6, 9, and 3, 7. So I hope you understand now for evaluating just functions overall in general, and the simple, don't let the wording trip you up. Just remember that you have to understand that domain as definition is x values. So I hope that helped, and I wait to see you next session.